In this video, we're just going to complete the first page of Notes 3.2 about polynomial functions. And we're going to build upon what we learned in section 3.1, where we learned that a polynomial function can be written in the form f of x is a sub n times x to the n plus a sub n minus 1 times x to the n minus 1, all the way down to a constant term, a sub 0. And remember, the a sub n's are simply real numbers. And then the exponents are non-negative integers, or really we can just say they're whole numbers. So they cannot be fractions. They can't be negative fractions that don't reduce to positive integers. Okay, and then we focused on polynomial functions of degree 2, or quadratic functions. Today, what we're going to start talking about is graphs of polynomial functions of higher degrees. So to begin with, one characteristic of all polynomial functions is that they are continuous, okay? The graph of a polynomial function is continuous. That means it has no breaks, no holes, or gaps. Informally, what that means is it's a function that we can draw without lifting our pencils from the paper. In addition, the graph of a polynomial function has only smooth, rounded turns. Can't have any sharp, pointy turns. And note, while graphs of all polynomial functions are continuous and have rounded curves, not all graphs that are continuous and have rounded curves are polynomial functions. So it only goes one direction. So with that understanding that graphs of polynomial functions are smooth and continuous, and they can't have any pointy turns, they have to have smooth, rounded curves, we're going to look at a few examples and try to identify which could be graphs of polynomial functions. Okay, so in the first graph, take a look at it, pause the video, and come up with your own answer, and then return. So can this graph be the graph of a polynomial function? Well, first, it is continuous, right? We could draw this function without lifting our pen from the paper, but it is not smooth. It has pointed turns, so no, the reason is that this has pointed terms. So it could not be a polynomial function. This next graph, is it continuous? Yes. Is it smooth? That means, does it have nice rounded turns? Yes. So this could be a polynomial function because it's smooth and continuous, and it has rounded curves. Okay, take a look at the third graph. And after you come up with your own answer, return to the video and see if you agree with what the solution is. So in looking at graph C, 1C, could this be the graph of a polynomial function? So here, this part is smooth and continuous, and this other part is smooth and continuous with rounded curves. But the issue here is this graph is not continuous as a whole. So this graph is discontinuous. We cannot draw it without lifting our pen from the paper because it has this break. So 1C cannot be the graph of a polynomial function. The simplest graphs of polynomial functions are what are called power functions. And a power function is something of the form f of x is x to the n. So like x squared, x cubed, x to the fourth. And on the next page, and n has to be an integer greater than 0. So on the next page, we are going to look at power functions and make some conclusions about that. We will do that together in class.